Let's get started. Thank you so much for coming, everybody. I know I'm in between you and lunch, so I will aim to be as entertaining as possible to keep you here. I do have some hoodies and some stickers down here at the front, so if you would like to grab a cute hoodie or a cute dinosaur sticker, please feel free. Modeled by my beautiful assistant here. So, welcome. My name is Jo, and I am a developer advocate at Dino. I am also a D&D enthusiast. Last year, I absolutely fell in love with tabletop role-playing. If you've not played it before, Dungeons & Dragons is a role-playing game where you have a group of players, and then you have a GM who is running the game, the games master or the dungeon master, they're often called. And they are the ones who are crafting the story, crafting the world, telling the adventure that the players are going to go on. And then the players play a self-crafted character who's going to explore, interact, and adventure through this world that the GM is creating. And today, I'm going to talk a little bit about my attempt to capture the excitement and the love that I have for these role-playing games in a web experience with the assistance of AI. And I know AI is a contentious topic at the moment. There's a lot of noise around AI. Some of it is justified, some of it is not. So before we get swept up in hype and backlash, I would like to give us a little bit of grounding in AI in games generally, because while AI does feel like a very disruptive force at the moment, the idea of machines helping us to create game content has actually been around for a long time. It's not new. The games industry has been doing it for decades. Procedural generation, which is arguably a very early form of AI, has been quietly shaping game worlds for decades. It's been happening since the early days of the medium. So what is procedural generation? It's rules-based, deterministic, often actually quite elegant. So the idea is you give the computer a seed, some sort of set of constraints, and it will build something algorithmically based on your constraints. So maybe a dungeon or a landscape or a table of loot. And it's been doing that since the early days of gaming, as I mentioned. And this talk isn't about replacing writers, replacing developers, replacing designers. It's about using these tools to augment our creativity or to automate our creativity. It's about understanding how these tools work, what they offer, and how we can use them responsibly to build richer, more responsive game experiences. So let's start by taking a look back into the past and what has come before. So if we go way back to the 80s, Rogue used procedural generation. There's also Elite, and there is also Dwarf Fortress. So Elite used procedural generation to create this very vast universe that you were playing the game in using really simple mathematical algorithms. And Dwarf Fortress takes that a bit further, and it uses complex interconnected systems to generate a deep and unique world history. It used generative AI to create the terrain, to create the characters that you're engaging with, and really builds up this sort of emergent gameplay. And procedural generation is interesting because it's not trying to be too clever. It doesn't understand your narrative. It doesn't understand the aesthetics of the game that you're building. It's just an algorithm which is following a set of rules that you set, this set of constraints. But yet it's managed to produce these very memorable game experiences. It's sort of there just quietly doing the boring bits that you don't want to do in the background, the unglamorous work that makes more modern games feasible. And these earlier games were running on machines that have less memory than your watch does now. So procedural generation was a necessity because we needed to generate entire galaxies, entire maps of dungeons on machines with just very little compute power. And procedural generation is very efficient. As I mentioned, you give it a seed, and it can give you an entire universe based off of that seed. And if we fast forward to like the 2000s, we've got games like Spelunky, which some of you might have played, and Minecraft, where procedural generation has become more of a design choice. We get this nice replayability, we get surprise, and we get emergent gameplay. It's rather than a necessity because we have less memory, it's become more of an aesthetic choice. And today, procedural generation is all over gaming. You'll see it everywhere without seeing it. So terrain placement, tree scattering, foliage variation, these are all handled procedurally. There isn't a designer placing every single leaf in the game. So when we're talking about procedural generation, we're not just talking about content, we're talking about the infrastructure of the whole game, and it's a scaffolding that lets the artists and designers focus on the bits that matter more than where every leaf is going in the game. So the final bit of background that I would like to give you is this game here, which inspired my own interest in procedural generation and storytelling. And it demonstrates kind of how far you can go with procedural generation for storytelling rather than just, leaf placement. This is Wildermyth, and if you've not played it before, it's a tactical RPG, but it's got a twist to it. So instead of a fixed narrative, it builds stories around the characters that you create and the choices that you make. So it's not just generating maps or loot, it's actually generating the myth as you play. So you have a character, the character will age, they will go on adventures, they will form relationships, they will suffer injuries, they will retire, they might even die. And the game doesn't just track those changes, it weaves them back into the narrative. So a character who retires in one game might pop up as a wise old sage in the next game. If your character has chosen to poke a rock and has now got an arm made of rock, that then becomes part of the myth of this world. It's a system that feels like it's hand-authored, but it isn't. It's procedurally generated. And the way that's done is it's authored in fragments, and those fragments are then stitched together to make a story that feels like it's almost been made for you. And Wildermyth is interesting. I don't know if you can see. So this is the way that it looks when you're playing the game. It's sort of this 3-panel comic idea when you're not in the battle. So this is how they're doing the narrative. And you can choose through a tree of options how you want the story to change and how you want to change the data that has been given in order to change what is generated. And it doesn't generate stories from scratch. Instead, it's got all of these choices of different story outlines, which are sort of like modular templates with branching logic. So the story beats change depending on which branch of the tree you choose to go down. The stories aren't rigid scripts, they're scaffolds to create a whole myth throughout your game. And the choices that you make, the relationships that you build, all mold the story as it goes. And it gives the illusion of this really bespoke storytelling that changes as you make choices. It's a hybrid model, it's part authored and part procedurally generated. And it's a really nice example, this game, of structured generative design, where the output is flexible, but the framework is quite rigid, and rigid enough to maintain a certain amount of coherence. It's not trying to be too clever, it's just trying to be consistent. It's trying to give you something that makes sense. But while Wildermyth is quite impressive, it does have some limits, and once you've played the game multiple times, you'll start to see the repetitive nature of it. So maybe maybe your character doesn't touch a rock, they touch a tree, and now they've got a tree arm instead. you start to see the templating that is happening within the game and start to recognize the different story beats in the different branches. So there's a ceiling to its replayability. You can only author so many story fragments, and you can only anticipate so many different combinations. And this is the problem with procedural generation. It's deterministic, it's rule-bound, it can remix, but it can't invent. And eventually you'll start to see the repetitive nature of it. And as a player who's played it maybe a few too many times, it starts to feel a bit repetitive. You start to see the seams in the generation. So the joy of D&D and similar role-playing games lies in the blend of structural play. We've got a lot of rules in D&D. There's, rules for what your character can do. There's rules for what the bad guys can do. Your GM will create rules of what, the physics of the land is like. But within those rules, you are fully improvising. It's whatever you can think up in your brain. And we can absolutely, if we wanted to write an app of this, we can codify those rules. We can codify our character stats, our enemy stats, but we need some sort of creativity. We need that human-like intelligence in order to make it actually interesting, to make it playable, to make it repeatable, and to give our story some sort of narration. And this is where generative AI can come in as a compelling tool. And generative AI, I'm sure we've all tried it out by now. It doesn't rely on predefined fragments. It doesn't need a library of authored content. It can generate new material. It can write us dialogue for our characters. It can even write us code on demand. It's non-deterministic, so if we give it the same prompt twice, we're going to get two different responses out at the end. And we've all seen it. Like, sometimes the responses are brilliant, sometimes they're complete nonsense. And that's kind of the trade-off of using generative AI. The models are just pattern matchers. They're operating on statistical likelihood, which is why they can sometimes surprise you with something brilliant and why they can sometimes hallucinate something that makes absolutely no sense at all. And in game design, that unpredictability can be quite powerful. Like, it could create you a world that you could never possibly imagine for yourself. It could make you stories that feel spontaneous, that feel unique, but it could also create you something that makes no sense at all, or that is just confusing. So we have to start thinking, if we want to use generative AI to build a game, how can we constrain it? How can we validate it so that it is safe and fun to use? So generative AI isn't a rules-based system. It's a statistical engine that is trained on huge amounts of text. And all it's doing is predicting the next thing that is going to happen, the next token in a sequence based on what came before, which is computationally expensive. Each token prediction needs billions of matrix operations in order to be output. The model doesn't know what it's trying to say. It has to do this computation for every single word that is going to come out, every sentence, every paragraph, and there's no shortcut for this. So if we're running a large model, like something GPT-sized, then we're looking at potentially seconds between responses, even on decent hardware, which for a game is just not really, that's not going to work. If I'm trying to talk to a character in a game and it's taking literal seconds for them to say each word in a sentence, like, this is not a good real-time game experience. And it's not just a speed issue, it's also an issue of memory requirements, like how much GPU load am I going to have to consider? So if I want to use a generative AI model, is there a way that I can do it that is powerful but maybe more lightweight in order to use it in a game? I need to think pretty carefully about which parts of the game I should use generative AI for, and which parts maybe are better with procedural AI. Not everything in the game also needs to be done on the spot. Could we potentially generate things that could be pre-baked in, things that could be cached? Or can I just swap out and use procedural generation instead? So my thinking was for this game, could I take the structural approach of procedural generation and templating and then blend it with generative AI to make a compelling game, something like Wildermyth that then won't run into those problems of repetition? So instead of relying solely on pre-authored story fragments, we can use generative models to fill in the gaps, to add flavor. We give it a base, and it adds that variation and that nuance. We could potentially pre-generate storylines, outlines, situations, dialogue, and then incidental detail could be added on the fly by the generative AI. And that's sort of the key to this whole idea. Generative AI isn't a replacement for authors, for designers. It's a tool for enrichment. And if we use it well, we could make a whole world, a whole universe that feels alive. If we use it poorly, we're going to get something that feels totally inconsistent and impossible to play. So let's talk about how we will keep it on the rails, how we make it give us something that is actually compelling. As I mentioned earlier, generative AI doesn't know what it's saying. It's not generating, it's not verifying itself. It's not giving us like facts. It's just predicting plausible text. And that means things can and often do go wrong. So if you're using generative output in a game, especially for dialogue, you can't just drop it in raw. You have to have some sort of validation on it to check that it makes sense, to check that it fits the world, to check that it doesn't contradict itself. Quite often in the early game when I was building, it would, give me dialogue for a character and then just give me the exact opposite thing to say as the next thing to say. It just didn't make any sense, and it ruins your sense of immersion in the game. So we're going to need to have some sort of validators. We're going to need to have some sort of filtering on the output and just general sanity checks to sort of keep it within sensible guardrails. Because, we've all seen the weird shit that AI can produce. Without guardrails, it's going to feel super uncanny and weird, and not in a good way, in like a broken way. So one way that we can help sort of tame the chaos of this output is by adding some structure to it. And the way that at least JavaScript developers like to add structure to things is with JSON. Just because the model is non-deterministic, it doesn't mean that our schema has to be. So we can define a super clear structure. Let's say we're designing a character. So a character has to have a name. They have to have a place of origin. They have to be part of a faction. They have to have a motivation and a backstory. So we can constrain the model's response. We can say, it has to have these things. If it doesn't have these things, go back and do it again. And now we're no longer asking AI to make us a whole novel, like, write me this world and this story and these characters. We're just saying, write me this character has to be this shape. And then we can write checks to say, well, is this the shape that I expected it to be? And I can run tests on that. And I can reject anything that doesn't pass the test and ask the AI to do it again before it's ever even reached the player. And we can do all of this without sacrificing the richness of the content. It's not perfect. Obviously, the model can still hallucinate. But by wrapping the output in a structure, we shift the problem from what on earth did you say to does what you said fit what I was expecting? So let's have a look at a type for a schema to fit a universe. So this is a suggestion that I made. So we've got our universe has to have a genre. So are we in a sci-fi world? Are we in a fantasy world? Are we in the Wild West? What is the tone of this universe? So is it grimdark? Is it My Little Pony? Like what's the tone? How large is it? Do we have a tech or a magic bias? How many factions are there here? And so on and so forth. Like, this is me trying to be as clear as I can in order to get the AI to give me worlds that actually make sense, that we can then build a story around. And then what we do is we instruct the model to follow these types and return JSON only. So small guardrails like stripping code fences, asking for strict JSON parsing, that can catch a whole load of bad outputs from our AI. But even with a defined shape, we might struggle with quality for our generated data. And one of the simplest ways to improve generative output is to stop treating it like a one-stop shop. Instead, we want to think in passes. First pass is going to be our rough structure. Second pass is the detail, and then the third pass is the polish. This is a multi-pass situation. So if we're generating a world, maybe the first pass is going to be the world outline. The second pass is going to be give me cities, give me architectural types, give me factions, and then the third is going to be give me the local history, give me the character relationships. And each layer is going to build on the previous one, adding depth, but adding depth within a structure. It's already got some constraints. And because each pass is scoped, that gives us the AI a chance, well, it gives the AI less of a chance to go off the rails, and we can then validate each pass as we go. So, as I said, rather than asking the AI to do everything at once, we break the task into manageable chunks, and each pass of this task has a clear goal with a defined schema and a bounded context window, which, yes, it's going to be slower, but it's going to be much more predictable and much more testable. And in a production environment, that's what really matters, because generative AI isn't magic. It's software, and software needs structure. So the thing that generative AI struggles with is context. It doesn't know what it said before. It doesn't understand what matters to you as a developer or as a gamer. In traditional systems, the context is explicit. It's stored in variables, it's passed through functions, it's tracked in state. And in generative models, it's implicit. It lives in the prompt. So it's a bit more fragile. So we can't assume that the model knows what's relevant to us. We have to tell it every time. We have to be really explicit in our prompts, which can make your prompts quite unwieldy. It feels not very glamorous, but it is essential. Without context, we don't get narrative. We get noise, which means you have to be really careful when you're structuring your prompts, which also means you have to be quite careful when you're managing your token budgets. You want to design workflows that help you preserve the continuity. So with all of that in mind, let's actually try building something. So to generate this game world, we are going to use generative AI, but we need some sort of grounded randomness. So we're going to try and make enough variation that the world feels fresh, but enough structured content that it feels consistent and actually playable and actually makes sense. So this grounding data is called seed data, and obviously you can hand author this seed data if you're an excellent author, or you can generate this seed data and then edit it. The first ever AI game that I built, so part of my falling in love with D&D was hoping that maybe one day I'll be able to be a GM. At the moment, I'm just a player. And the idea of being a GM is you've got the context of the entire world in your head, and this just feels like a lot to me. So the first ever AI game that I made was just a little chat where I could practice being a GM, and I got the AI to create 3 characters for me, a wizard, a rogue, and a fighter, who would react to the story that I was trying to tell the AI. It wasn't grounded in any way, so quite often the characters barely took any notice of what I was typing in as a GM. So it didn't feel coherent, it didn't feel structured, it didn't quite work for me, which was, I was hoping to get GM practice. What I ended up getting was GM practice for having a bunch of players who weren't listening to me and and wanted to do their own thing. So we're going to create a bunch of seed data, and were I a better writer, I might write the seed data myself, but we can generate this seed data as well. So this is a bunch of universe seeds with a wide range of categories. So we've got sci-fi, we've got post-apocalyptic, we've got surreal. You can see all of these things in here. And then I wrote some prompts which are going to pick a random seed and then build that out into an actual universe. So let's just have a look. What have we got in here? We've got a contemporary realism seed. The category is contemporary and realist. Description, only modern world with no supernatural or speculative elements. That's not my idea of a fun role-playing game. But we could, as you can see here, we've got a huge list of different options. So we're going to pick a seed, build it out, give it some tone, some scale, and some thematic bias. So this is an example of what a world-building prompt might look like. We give the model some clear instructions on how we want the return data to look, and then we're going to get it to describe the universe. AI performs best with short, specific tasks and clear schemas. So I don't know if you can see that here, but it says, you are a world builder AI for a proc-gen and gen AI assisted RPG. You accept a seed JSON and return only a JSON document describing an internally consistent universe outline to ground subsequent generation runs. I then have a list of requirements for what I want a universe to look like. So these are just a description of that JSON that I showed earlier. So we must have a universe type, we must have rules, we must have scale, blah, 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 blah. And this is just a bit more of that prompt. So we can also give it behavior rules for how we want it to operate. And then importantly, down at the bottom, you will see there's a thing where I say never. So one of the weird things, if you've ever asked generative AI to make you a world, it's really keen on this place called Eldoria. If you ask ChatGPT to imagine a land or a universe or a world, it will many times out of 10 give you a place called Eldoria with someone who lives there called Elvara. And there's a whole Reddit section on Eldoria and what on earth this is about. But it does mean that your game can get quite repetitive. So one of the things you can do in a prompt is say, don't do this thing. So don't tell me about Eldoria or any variation on Eldoria, because otherwise the game can get quite repetitive. And the great thing about prompts is we can even prompt the AI to check its own output. So if it gives us invalid JSON, we can say, go back and fix that. And once we've generated some universes, we can randomly select one, and that's going to be our base for our next round of generated content. And from there, we can generate more and more world details. And these are the multiple passes that I mentioned earlier. So the second pass is going to build cities and factions and geography and history and cultural flavor. And we can even define things like naming conventions, like how does my city sound? How are factions labeled? What kind of linguistic texture is there in the world? It's aesthetic, but it's also functional. These are the things that make your game world feel real, that make your game feel compelling. And this is going to become the context for everything that we create next. So our characters, our quests, our dialogue, our mechanics. The world has to be grounded, and then the rest can be built on top and make sense. So the first step in generative design isn't generation, it's actually definition. We need to set these constraints. That's how we get worlds that feel authored. And then, so as I mentioned, we can start adding depth, so our history, our geography, not just terrain, but also cities, other settlements, what's the local dish, what's happened in the history, are there particular points of interest? And this is where generative AI starts to feel really useful, because writing all of these things yourself is just such a monumental task. And you can add in as much definition as you want for the schema of your city. Your own imagination is the limit here. So, we're not just going for name and population, but like, what is the founding myth of this city? What are the key landmarks? What's the political sentiment? And then we can let the model just fill that in for us. And then each city becomes a node on a narrative graph. And each city has relationships. Each city has its own little factions. There could potentially be trade routes. You could have rivalries between different cities. Maybe a city is known for a particular festival or a historic event or a strange architectural style. Your details don't need to be exhaustive. They just need to be evocative enough to make a player want to explore them. And because we've already defined the world's tone and aesthetic, the model has something to work with. We're building on a foundation that already makes sense. The constraints mean it's not generating in a vacuum. It's not going to give us just a bunch of garbage. It makes the output feel coherent, not just because the model is clever, but because our scaffolding is solid. I'm sure everybody here remembers the Willy Wonka's chocolate factory debacle that happened in, I think it was in Edinburgh, where they got AI to generate a script for this Willy Wonka's chocolate factory experience, except AI didn't understand that humans can't just magic fairies and lights out of the air. So these poor actors were trying to follow a script that was written with no constraints put in. If you haven't seen that story, do look it up. It's very funny. So let's take a look at an actual generated universe. So I should have one here, hopefully. So here we have, let's find an interesting city, shall we? The city of Sindralith, founded during the aftermath of, oh wait, I'm not even showing it to you. There we go, so this is my code. And now I'm not going to be able to read that to you. There we go. Founded during the aftermath of the binding of flame, when the first mage engineers learnt to stabilize quantum ley lines. Kind of cool. Kind of sounds like somewhere I might want to explore. And in there we have the Prism of Council Hall. We have the Amberforge district. We have a whole load of exciting things. And these just go on, and we have a history. So On the ancient plains of Thalis, scholars and shamans discovered that fire long seen as divine elements was deeply entangled with unseen quantum forces. Could maybe have done with a tiny bit more constraints there. But as I mentioned, the more definition we add, the more constraints we give it, the more real sounding these cities can be. So let's talk about cost. If you've ever tried to build anything with generative AI, and you've used commercial APIs, you know that the meter is always running. Every token, every call, every retry, it will add up to being quite expensive quite quickly. And when you start adding this idea of this multi-pass layering, it's going to add up quite fast. So you're not just burning compute, you're also burning your budget. But here's the twist. You don't actually have to. Everything that I've shown so far, those worlds that I just showed you, that was all done entirely offline using local models. No API keys, no rate limits, no cloud dependency, just your own hardware and a little bit of configuration. So I use a tool called LM Studio in order to do this, which allows me to run local open source models, and then I can swap out the OpenAI calls for local calls instead. And I can build systems that scale without scaling my cost. And I'm running this thing on a little Mac Mini that lives underneath my desk. Yes, it is potentially slower, and yes, it does take tuning, but it's free, and it's mine. And a Mac Mini runs on very little power. One of the things that people talk about a lot when they talk about AI is how much power it's using, how much water it's using. We want to be trying to do this in as efficient a way as possible and as ecologically friendly way as possible. And yeah, using local models is an interesting shift because it's not just financial, it's architectural. We can remove our dependency on external APIs and sort of regain control a little bit of our budgets. We can potentially iterate faster without worrying about using up tokens. We can deploy offline, and we can build systems that are a little bit more sustainable. In a world where generative AI is often framed as extractive, that really matters. So LM Studio is a local inference platform, lets you run open source models on your machine with no vendor lock-in, just raw model execution. There's a whole bunch of open source models out there, pre-trained, ready to use, really nice user interface. And this is an ecosystem that is growing super fast. Hugging Face has literally hundreds of models that are out there available for you to use. And we're talking like really tiny models. Like I've got one installed on this machine that I think is 3 gig. Let's see if I can get this one to talk to us. So this is, you can't see it, but this is a Surface. Like this is basically a tablet that is running this this model. So let's see if we can talk to it. So this is what LM Studio looks like. We can install different models. So you can see here I've got one that's 4 gig, one that's just 720 meg. Why don't we try talking to that one? So let's go back. Start a new chat. We'll talk to the smallest one, see what it does. Can you tell me a fact about cats? Cats can rotate their ears independently up to 180 degrees. Who knew? Any cat owner, I think. But that was pretty fast. It's running on a tiny machine. It's not expensive. I could download this model for free. It's not just a gimmick. Like, this is an actual usable system. So then, once we've got a local LLM running, we can use OpenAI's NPM package, but instead of pointing it at their APIs, we can point it at our endpoint instead, our local endpoint, and talk to LM Studio. And then I just wrote a tiny client adapter on top of that, which is OpenAI compatible, that points to my local LLM server. And it gives me the best of both worlds. I've got easy dev ergonomics, but I've also got this offline, cost-free ability to run this multiple times. And this is just a super basic example of what that might look like, using the OpenAI client, but pointing it at localhost and then passing instructions in a prompt. But is it possible to do this on the fly? The idea of generating quests and dialogue and story beats in real time sounds like really cool, but the reality is obviously shaped by latency. Generative AI is slow, it's inefficient, because it's doing something complex. It's sampling from a potentially huge space, token by token. But the landscape is shifting. We saw that response to my asking about a cat fact was pretty fast on this tiny machine with a 100 meg model. We're seeing inference times drop to a few seconds, so it's not instant, but it is potentially viable, especially for things like flavor text or ambient dialogue or side quests that don't block our sort of main gameplay. And as I mentioned earlier, we don't need to generate everything in real time. We can generate enough stuff beforehand to make the world feel responsive, to make our NPCs feel alive, and then do the real-time stuff as an add-on on top of that. It's an architectural problem. We want to pre-compute as much as we possibly can, cache intelligently, and then reserve real-time generation for the moments that matter. It's not about replacing authorship, it's about augmenting it. And with our local models, we can absolutely control the way that we do that. And on the website, that means treating generation like you would your async I/O. So you background your requests as much as you possibly can. You build in an optimistic UI that's going to fill in the gaps or add in a fallback if your response doesn't come back as fast as you might hope it would. So just for illustrative purposes, this is a tiny little Hono app. It's asking the local LLM for 1 or 2 lines of ambient narration with a hard 2-second timeout and a safe fallback. So this little endpoint is it's kind of like a safety-first version of real-time generation. So the client is going to post a tiny payload, like an NPC name, their current mood, and a bit of context, and then the server is going to call the local LM Studio API. And then we can wrap that whole thing in this abort controller with a 2-second budget. So if our response isn't back in time, we can fall back to something generic but believable. This keeps our UI nice and snappy and predictable, and the point isn't to generate everything live, it's to add a pinch of bespoke flavor without risking our user experience. So let's talk about the architecture of the game itself. We've split it into 3 parts. We have the author, which is the part that generates the universes, the dialogue trees, the flavor text, all using our local LLMs. Then we have the API that serves a simple random endpoint that generates one universe based on our seed. And then on top of that, we have a web app, which I've built with React and Vite, that is going to actually render the game. It's going to draw us a little world. It's going to give us a chat UI and some dialogue options. And then each time we run the author, we output files to an output folder. The API picks one at random and serves it to us, and that's going to be the world that we play in. The API then returns a random bundle from the disk. If you've not seen Hono before, it just allows us to build a small functional server. And I'm using here Dino's built-in file APIs in order to do the rest of the work for us, which allows us to just read the files that we created earlier. So when I showed you that file full of cities earlier, that's an example of one of the ones that we could read in here. So on load, we then fetch that random seed state, and we populate a chat UI from the information that we're given. And then to make this a game, rather than just, because at the moment all we've talked about is world building. We haven't talked about story building. We haven't talked about gameplay mechanics. So for this particular game, we're going to add in some dialogue trees. Now that we've generated worlds, we can generate our characters, and then once we've generated characters, we can start generating dialogue for those characters. But the dialogue needs to flow. So we can think of a dialogue tree like a branching graph of conversations. So each node contains an NPC line and then a set of player options for which one they want to choose to respond to that line. And each option may apply effects like changing sentiment or setting flags, and that's going to point to the next node or the end of the conversation. And it lets our stories adapt to allow the players to make choices while staying coherent. So this is what a dialogue tree might look like. We can generate these as just JSON graphs and then render the character lines in our app, presenting the player with the different options. So each response might offer a change in sentiment from the character, or may prompt the character to offer you an item, something like that. And then choosing an option in the UI is going to show the character's response and then follow up with some more chat or end of story. So this talk is already running quite long, so let's actually have a look at the game itself. And when I say game, it's a first draft, it's an experiment. It was more to test a theory, so there's not a huge amount of game element in this game, but let's take a look. So this is my storyteller game. And we have been, let's see if I can bring this over here. In the copper-sanded dusk of Grimford, steam hissed like 1,000 nervous whispers, and brass conduits glowed faintly against soot-blackened brick. We have been presented with Leora Gearsmith, who says, another traveller in Grimford's smoky alleys. What brings you to my workshop? And we have 3 choices of things that we can say to Leora. Just passing through, mind your own business, which, as we can see here, is going to be presented with a -10 on sentiment. I'm looking for the newest diesel tech. Heard you know about quantum diesel, or I can offer a decent price for your old gear. Which one should we say?
Go for the third one, biggest step. Yeah.
Okay. Always ready to upgrade my collection. What's on the table? A flicker of emotion crosses Leora Gearsmith's face. Let me see what you've got. Oh, wow. And that was the end of that game. Let's start another adventure. Yeah, some of these are more padded out than others. A visitor, care to hear my latest chronicles? Yes, tell me about your chronicle. It's a tale of heroes and bureaucrats, dear friend. Do you have time to listen?
Give me the punchline.
Thank you. Hero's quill broke mid-sentence and the bureaucrat signed a blank decree. Sure. Yeah, so branching dialogue to a certain extent, and things that make sense to a certain extent. Obviously, this requires a huge amount more work, but this is the start of an idea, and I wanted to, get your sort of AI and ProcGen ideas flowing. Like, these are things that you could take and build into something that I think could be really fun and exciting. And it's something that I want to definitely develop further. And like I said, there's not much game in this game yet. There's plenty more things that we could do. We need to actually put a plot into this game, and a reason why we're talking to these people. And there's a whole load of stuff I could say here about storylines and plot, but we are running on in time. So I would just say thank you so much for coming. Thank you for listening. If you do want to build anything like this, do come and have a chat with me at the end. I would love to hear what you're thinking about building. And yeah, thank you so much for coming.